All right, so let's take a look at section 1-2. In this section, we're going to take a look specifically at expressions. What is an expression? Who could tell me what an expression is? And you could give me your own definition or a mathematical definition, but what's an expression? Yeah, it's just like a number sentence, but there's no equal sign. So just like an equation, but again, without an equal sign. So what we'll notice here is we're going to see the difference in this chapter between saying evaluate an expression, or solve an equation, or simplify the expression. When you hear expression, you should know right away there's no equal sign whatsoever. But you can plug numbers in and see what the value of that expression is. But you really don't want to use the word equals here because you're not solving an equation. Okay, I'll go over an example of this when we get to it. But I want to make sure that's clear. So we've got a bunch of definitions here to start. It's a numerical expression, a symbol or group of symbols used to represent a number. So for example, if you had something like, that's an expression, 3 times 4 minus 5. And we can simplify that expression, but we can't solve anything here. We don't want to use the word solve. It doesn't make sense. There's no equal sign, so we cannot really solve. So simplifying this, we know it's going to be 12 minus 5 is going to give us 7. Okay? This is going to give us 7. Value is the number represented by the expression. Equation is simply having two expressions and putting an equal sign between them. So both sides of the equation are considered expressions. We already know what an inequality symbol is: less than, greater than, less than or equal to, or greater than or equal to. Okay, so we know that those are comparative symbols. So with an equation, we always have an equal sign, so we call it inequality. An inequality, the same thing as an equation, but with an inequality symbol, less than or greater than. Is this unclear at all? Has everybody seen this before at some point in time? Come on. Has anyone seen this? Has everyone seen this at some point in time? Okay, so we got... Okay, so Christian Chandler. Let me work on names, so don't tell me anything. Alex?
Yeah.
Alex Alvarez. Chandler. Chandy, right? Chandy. Son, not Chandler. Chandler, what's your last name here, Chandler?
A1.
What is it?
N-A-Y.
N-A-Y?
Yeah.
L-O-Y. We got Will Weiser. Have you seen Will Jr.? This is, it's W-I-S-L-E-R, which is Whistler.
Whistler, yeah.
From the movie. We got James Narski. We got Jeffrey. Jeff, what's your last name? Friars. Daniela Santiago? No, what is it? Piera. Sarah. And Emily.
Alright, these are your temporary ID cards. That's why they do not have a picture on them, okay? You'll get your real ID card in 2 or 3 weeks, however, this is so that the lunch line will go faster. Okay, so they're still required to be in the building. You must have them in the lunch line. Miss Coop knows that I handed these out to you. So if you don't have them, what do you think will happen? Possible, yeah. So make sure you have them on your purses at all times. Thank you. And I have yours if you want to come by my office. Alright, come to your office. You know, you're there.
Oh, yeah, of course. You know?
Yeah.
Behind the library in the back there? Good. Okay. Let's take a quick look at example 1. Fill in the blank. Less than, equal to, or greater than. Very simple. You have to know your laws of arithmetic here, though. Try this one first, then we'll go over PEMDAS real quick to make sure we're clear on that. Okay, should be finishing up at this point. On the left side, what do we have? On the left side.
13.
Where'd you get 13? Explain.
27 divided by 3 plus 1.
Good. Do 27 over 3 first, which is 9. 9 plus 4 is 13. Very good. Alex, on the right side?
I got 11.
All right, so is 13 greater than 11 or less than 11?
Greater.
Yeah, clearly it's greater than. So there's our answer. Okay, very simple. Okay, make sure we understand the ideas here. Now, remember, for PEMDAS, what do we know? What do we know for PEMDAS here? We're going to go over it in a minute, but who remembers the one hiccup with PEMDAS? There's some, because we all know what the expression means, right? But there's something along the way that we have to remember.
Multiplication and division are at the same time.
Yeah, whichever one comes first from left to right. And
Addition and subtraction.
addition and subtraction as well. So, we're going to see an example in a moment, we'll go over that. But that's the only thing you have to really kind of think about for PEMDAS, straightforward. Some quick reviews. When you hear the word sum, we have to remember to add. When we hear the word difference, remember to subtract. When we hear the word product, to multiply, and quotient, to divide. Okay? In your classes in the next few years, your terminology becomes much more important. So right now, this should be a review of terms you've used already. But please recognize that when I tell you stuff like definitions, this, again, very simple, you need to know what those mean. Okay, you're going to utilize those terms a lot, especially when it comes on to taking like an SAT test or an AP exam. A lot of the words on there are mathematical terms. It's not going to be very like simple terms. You're going to use all the words you've learned over the last 10 or 12 years of learning math. Power, give me an example of what power means. And I know the definition is there, but what do you think about when you hear power? When you hear power?
7 to the 4th power.
Yeah, 7 to the 4th power. Something multiplying by itself several times, right? The base itself, in that example, for 7 to the 4th power, what's the base? 7. Okay, it's the number that's lower if it's easy to remember. Base meaning the bottom. Give it that way. And the exponent is the number of times you multiply it by itself. So in that case, it was, for 7 to the 4th, 4. Okay, 7 times 7 times 7 times 7. What if it's to the 0 power? And it's 1. Okay, remember, anything to the 0 power is always equal to 1. Like I said, we're going to go through this quick today because this is an easy lesson. All right, substitution principle. Something that seems to be, what's the word? Almost like not useful until you recognize how many times you're going to use it algebraically. Okay, mathematically with arithmetic, we're going to know, for example, if we had a quantity such as, 13 minus 2, and it's in the middle of an equation, and there's all this work that's going on, I can replace that with 11. And that's what substitution principle means. You can substitute something that's equivalent to the previous expression. Okay, so we're going to see this more with algebra. With arithmetic, it's simple. But we're going to see where we have stuff like this. Okay, imagine a system of equations where you have two equations, two unknowns. And we're going to talk about this throughout the year. Many of you probably saw this last year or the year before. So you have an expression that equals y, 2x minus 4. You can substitute it in here for y. That's why substitution principle is important, not for arithmetic. This is common sense, right? Simplifying. Over here, not as much. Make sure that you recognize that the expression that is equal to y is 2x minus 4. So you can substitute that expression here for y. Okay? I'll try and use the pointer more because I forgot that doesn't show up there. Okay, substitute it for y there. All right. PEMDAS. So we know again, parentheses, exponents. Then for multiplication and division, just remember to go from left to right. So let's quickly look at an example of this. So let's say we've got, before I get to the example, we have 2 minus 3 to the second power divided by 3 times 6 minus 4 plus 1. Okay, and the question says, evaluate the expression or simplify the expression. It does not say to solve anything, right? So evaluate the expression or simplify the expression. Step me through it. Anyone ready? Give you another minute. Sarah, what would you simplify first? Yeah, because you see PEMDAS starts with the letter P. So 2 minus 3 gives me? Squaring that gives me? Okay, so we start by evaluating this as -1, and we're going to square it, so this ends up being a 1 here. After that, Sarah, what do we look for?
Then you look for either multiplication or division, but division's first, so you divide 1/3.
Okay, 1 divided by 3 is just 1/3, right? So I've got 1/3. I'll continue writing it down. Go ahead.
Then you multiply it by 6, and you get 2.
Just draw arrows so we know where they're all coming from. So we take 1/3 and multiply by 6. Good, to give us a 2. 1/3 of 6 is 2. Next.
And then you gotta go for addition, subtraction is first, so you add 1 to get to
All right, so 2 minus 4 gives us -2 plus 1. -2 plus 1 is going to give us -1. Okay? So please make sure that when you're doing this, you remember to look for the grouping of multiplication and division, whichever comes first, left to right, and addition and subtraction, the same thing. That is an answer. Check your work, please. Check your work. If you made a mistake, try and identify it on your own. Try to figure out where the mistake is. That's part of, that's part of being a really good student in math, is being able to go over your work and identify the location of the mistake. When you're checking over your test, that's the same thing. Especially when you're doing something like a multiple choice, and your answer doesn't show up in the choices, you know it's wrong, right? So you have to go back and look for that mistake. So identifying your mistakes is a key in this class. We're all going to make mistakes in life. It's not a big deal whether you can see what they are. So my guess is if anyone made a mistake, would be maybe doing 3 minus 3, giving you 0 here accidentally, and then 12. Or, I don't know, possibly doing 9 minus 3 first, but it's the only thing I can see. Any questions on this one? Are we clear? Yeah? Okay. Let's go to the next. So first, define the term variable. We have a definition here, but what do you think of when you hear variable? What do you think of when you hear variable? Yeah, a letter that's a placeholder for some value. Okay, a letter or symbol, we could say. Because what we're going to notice is that we use letters for variables, but other things can represent variables. Okay, and they're not always Arabic symbols. Like we're used to the Arabic alphabet. Is that what we use in Arabic? A, B, C is Arabic?
Yeah.
Right? Okay, so sometimes you're going to see in science that a lot of symbols are Latin and Greek, most. Okay, so you see symbols like sigma, you'll see lowercase sigma, you'll see rho, you'll see epsilon, all these different symbols you're going to hear a lot, and you're going to use a lot. Why do you think they're also used? Why do you think those kind of symbols are also used?
I mean, in geometry last year we used alpha a lot.
Okay, for angles, right?
Yeah.
Or theta for angles also. Beta, sometimes angles, good. Why do you think they're used?
Well, because that's more of a set thing that you're using it for, like the alpha or the beta. It's always in angles, and like the alphabet is more for like X is always changing, but alpha is usually like a constant variable. Like it's a constant way to the right of it.
Yeah, so you're going to see that over time, traditionally, certain areas of math have adopted to use these specific symbols So you'll see theta, beta, and alpha a lot for angles. In science, in physics, for example, like rho, it looks like a lowercase p, is always density. It's a symbol that's been adopted to be used for density. So, I mean, obviously the regular alphabet that we use doesn't have enough letters to use those as specific symbols. So we go to other, sets of letters. So you'll see a lot of Latin and Greek both. All right, so we know what a variable is. Let's quickly look. So we have an expression here below, and the question is, if we know the value of those variables, can we evaluate that expression? Go ahead and evaluate that expression. To know your rules of fractions, obviously, for a common denominator here. How do I combine these fractions? Quickly, let's review this so we're all clear. Chandler.
Well, since they're not common denominators, you have to change 13 over 3 to 26 over 6.
And how do you do that? How did you know to do that?
Well, since you're looking at like the first denominator, which is 6, then you could change 3 and 6 by multiplying by 2.
Good. So recognize, and a lot of you guys can do this naturally, which is what you should be able to do, but recognize that 3 times 2 is really the prime factorization of 6. And we're going to see this later in the year. Right now it's simple because it's numbers. But what if we have expressions and variables and all this stuff? We have to combine like terms or combine with common denominators with variables. It gets a little trickier. So whenever you're in doubt, think about breaking up something into its prime factorization. 6 is really 3 times 2. What's missing here? 2 is missing. So put a 2 in the bottom, you got to put a 2 in the top. Okay, but it comes back to prime factorization there. As a result, 10 over 6 plus 26 over 6 is 36 over 6. Obviously, I should simplify that. That is equal to 6. Okay? All right, example 4. There are many answers to this. Let's see how many we can come up with. Last year's class, I think, came up with like 5 or 6. I wasn't too impressed. Let's see if everybody can come up with at least one. So using 5 2's, the number 2, 5 times, write an expression whose value is 7. You have to use the number 2 5 times, and you could only use the number 2.
Can it be negative 2?
You could use a minus sign, so sure. Any arithmetic symbol is fine. You could use a square root. You can use a time symbol, divide. You can use an exponent as a 2. Yeah, so negative technically you can, yeah? Once you come up with one, just raise your hand, and we'll put it up. Let's see how many we can get. Well, try at least each person try and get one. Somebody might have the same one as you, though, you know? Let's see how many as a class we can. Here you go. What do you got?
2 plus 2 plus 2 plus parentheses 2 divided by 2.
Very good. Okay, 2 plus 2 plus 2 is 6. Plus another 1 gives you 7. And there are how many 2's there? 5 2's. Okay, so that's one example that works. Chandler.
2 divided by 2 plus 2 squared plus 2.
Nice. Similar expression. Only thing he did was, instead of this 2 plus 2 here, he grouped it as 2 squared. What else? What else? There's another variation of the one that they both just gave. Anyone see it? Yeah, it's technically different because the power is different than that. So you want to write it, say it that way?
I haven't written it down.
Okay. Jeffrey.
2 times 2 times 2
2 times 2 times 2. Nice. Very good. 2 times 2 times 2 is 8. 8 minus 1 gives me 7. Alex.
2 times 2 times 2 times 2 to the 0 power.
Can't use a 0. Good idea though. I like it. Oh, you had the same one? What else? Not close to 7. What did you come up with? One that equals what?
7.7. It's the root of 2.
Square root of 2, 1.414.
2 root 2. And then like plus 2 plus 2.
Oh no. Yeah, because root 2 is irrational. It's not going to give you 7 ever, yeah. Nothing else? No one's used parentheses yet. With sorry, they have with that, but parentheses with like addition or subtraction, no one's used yet.
An exponent counts as 2, right?
Yes, it does.
Okay.
Yes, Jim.
2 squared plus 2 squared minus 2 over 2.
6 2s.
Oh, okay.
Good idea though. Daniela.
2 open parentheses, 2 plus 2 close parentheses minus 2 over 2.
What do we got? Let's see. 4 times 2 is 8. 8 minus 1 is 7. Perfect. Very good. Anything else? Two squared times 2 minus 2 over 2. Very good. Again, even though these look similar, I mean, they're written differently. One is 2 squared, one says 2 times 2. Okay, we're still using 5 2s, writing these differently. Obviously, 2 times 2 is 2 squared, but it happens to be both 2s then. What'd you get? You got one that's 16?
I used 16.
One, two, three, four. We got 5 right now. Any others? Okay, that looks good. One of your homework questions would be to do something like this. It's just to think outside the box, okay? Your homework tonight for this section looks extensive because it says 9 to 51 multiples of 3, but they're really, I mean, you see how quick it took us to do these? It's this level kind of questions. They're not difficult, so you should be able to get through it pretty quick. So you're definitely doing 1-2 homework tonight. I want to start 1-3 right now. Okay, we're going to go right into 1-3 just so tomorrow we can finish up 1-3 and get right through 1-4 to 1-6 because that stuff is all review. James. 2 plus 1. Oh, is that second power? Yeah. Nice. That's another one. I've never even seen that one before. What is it again? 2 plus
2 plus 2 divided by 2 to second power minus 2.
Okay, another good one. 2 plus 1 gives us 3. 3 squared gives us 9. 9 minus 2 is 7. We didn't even get a 9 before that. Nice. Any last ones?
What numbers?
It's at the next slide. Go to the next slide. Okay. All right, so we'll start 1-3 now, but you don't have to do the homework for 1-3 tonight. Okay, so we'll start 1-3, but that homework will not be due tomorrow. You can do it if you want, though, to get a head start.